They not only present formidable hazards themselves, but they also deflect every bit of air we want to use to keep ourselves off them. In this module, we'll look at the various forms of topography you'll encounter in mountainous regions, how our all-important winds are affected by them, and we'll begin to look at how to pick and approach a landing zone. Gas or liquid in motion is directly affected by the solid surfaces it comes in contact with. Just look at the rocks in this stream and remember the ripple effect caused by mountain winds, or 100 other comparisons for that matter. The stream is a good model. Studying the effect of the rocks on the water flow can be a very helpful exercise. Obviously, every bit of topography is different. We'll try to give you a basic overview of general types and talk about how they affect the regional winds, depending on 3 modifying factors: the regional wind velocity, the height, size, and shape of local terrain, and the presence of sun or ice fields. Valleys are the depressions between 2 ridge lines. In North America, they generally run north-south and may extend for up to 120 miles in length while averaging 10 miles in width. The lower portions of air masses flowing over a valley are modified to produce valley winds. Long, thin hills or parts of mountain ranges are called ridges. When ridges are aligned in the same direction and joined by saddles, they form ridge lines. Ridges are characterized by excellent upflowing air on the upwind side and turbulent downflowing air on the downwind side, extending as far as the center of the valley. Saddles are the low area of ground between 2 hills. The wind flowing through the saddle is being funneled, and therefore increases in speed and turbulence can be expected. The demarcation line may also be farther upwind because of this situation. The top of any hill or mountain is called the peak or crown, and it's usually the best place to land because the wind conditions are better defined than anywhere else. Pinnacles are a form of crown that occur in high mountain regions. They're a tower of rock stretching to 1,200 feet straight up. Wind conditions here are like those of a sheer ridge, with upflow upwind and downflow downwind. Circular backlash can be a problem, and of course the drop-off can be very extreme. A generally level area located on an otherwise steeply pitched slope is called a shoulder or ledge. This looks like a good landing spot. The trouble is circular backlash produced by upflow winds. You usually can't tell it's there till it finds you. The best LZ is right on the lip to avoid the backlash, and extreme caution should be used. Canyons are steep-sided gullies normally formed by streams running down a mountain. They usually extend up mountainsides at right angles to the valley. They can be tough to work in because they're narrow, often near vertical, and can contain valley winds with turbulence near the mouth or even upflows from daytime heating. Usually the only place to land is a sandbar or rock patch in the stream. Cirques are steep, deep-sided bowls produced by glaciers. The floor is usually 1,000 to 1,500 feet lower than the lip and often contains a small lake. There's usually an outlet to the east opposite a pile of glacial rubble known as a bench. This is about the only place to land. Wind spilling in from the west wall, sometimes cooled by ice fields, creates dangerous downflows and turbulence, and makes this a tough nut to crack. In order to put your knowledge of mountain terrain and winds to work, you need to note a few key points regarding landing zone selection. First and foremost, if you have available maps of the area, and you usually will, take a map recce, a detailed look at the contour lines, and get an idea of the lay of the land and corresponding wind factors. Next, once you're flying, it's essential to pinpoint the exact altitude of the LZ you're considering. Maintain a drop-off escape route until the last possible moment. Stay toward the upwind end of the terrain feature and so above the demarcation line. And having made an LZ selection, don't change it unless you completely abort and overshoot. With all those factors in mind, Begin initial reconnaissance passes of the LZ you're considering. These initial recce should be consecutive 40-knot passes at eye level in opposite directions. You need a minimum of 2, with each pass getting closer to the LZ. During these passes, you're assessing the feel of the various wind factors on your aircraft by paying attention to relative ground speeds, power requirements, and turbulence. And you're looking at the suitability of the LZ. A good recce checklist to constantly be repeating is airspeed, altimeter, outside. Once you've got a good feel for the situation, you begin your approaches to overshoot. These passes will give you the chance to confirm the winds and look at the LZ, the approach path, and departure path. They'll be much like your final approach, except you won't have to worry about losing translational lift. The type of approach we teach is going to go against what some of you have been taught, either in standard training or in training from other regions of the world. Our type of approach, the flat approach, was developed here in the mountains of British Columbia by Okanagan Helicopters, a world leader in mountain flying techniques. It's safe and it works. You're not trying desperately to arrest your rate of descent with less power available and little room for error like you would be with a steep descent. With the flat approach, starting less than 100 feet above the LZ and sticking to the contour of the hill, you can descend at a low rate and reach your landing site without flaring. You're also keeping a flat disc, thereby minimizing loss of lift, maintaining a fairly constant power setting, getting your ground effect cushion earlier, and maintaining a better collective position, resulting in high no-hover landings. It's easier to reduce your ground speed, and you can easily land at the termination of the approach with no large collective change. Even though your flat disc, low ground speed, and good collective position make it unnecessary to hover on landing, it's still a good practice, giving you time to stabilize for a smooth touchdown. The low hover should be 6 to 12 inches above the ground on the landing point or just shy of it. In high mountains, you may not have the power for a low hover. That's when you'll be thankful for learning the flat approach. As we said earlier, don't change your landing spot on short final. Abort and go around. If you haven't picked a specific spot in the area, prepare to terminate your approach in a hover, then creep to a good landing spot. Other key things to watch for are wind from the left can cause unanticipated right yaw. A light should go off in your head whenever winds are quartering from the left. Try to keep crosswinds on your right to save power. Make sure the aircraft is flown in trim. Crabbing is necessary. You'll use less power that way too. And above all, never land on a bad approach. Once you've landed successfully, you have to think about getting your aircraft back up again. Here are some key points to review before you attempt a takeoff. Which route do you take? Look for the longest you can. Check out obstacles like trees, rocks, or stakes. And if you're in rough territory, double check your skids. Where's the sun? How is it affecting upflow now? Do some hover checks to cross-reference your available power to what you'll need. Look for the drop-off. Get to it early. And of course, check the wind. It could have changed. Even a strong, steady wind can vary up to 90 degrees. Of course, now you can set out smoke or flags if you have time to back up your other indicators. When you're satisfied you've assessed the takeoff to the best of your ability, slowly ease the aircraft into a low hover, check the center of gravity and power requirements. If it's all clear, slowly ease your cyclic into forward flight following the contour. In other words, slide off the mountain. This contour takeoff uses less power, maintains ground effect into translational lift, uses a smooth application of power with no droop, and keeps you from spilling the disc because it stays pretty much flat. Again, it's safer and more effective. A couple of other points about the takeoff. Make sure you've got enough collective to complete the takeoff you've chosen, and check your cyclic for load distribution or other problems on the initial hover. Discovering an abnormal response later may be too late. A basic understanding of the terrain and topography will not only help you to predict the wind factors you'll have to deal with, but will also give you a head start in successfully completing your mountain operation, no matter what that operation may demand of you and your machine.
Okay guys, so just so everybody's clear, you're going to do your wrecking on the upwind side, then you're going to transfer landing once you complete that wrecking.
The most important phase of helicopter mountain flying is the reconnaissance. You need to carry out recce's prior to every landing here. The winds have a dangerous habit of reversing themselves whenever they feel like it. Once you get close enough to the mountain to select a landing zone and begin to make recce passes, you'll be working in the boundary layer of winds, although at different points on the mountain, many other wind factors affect you. The contour crawl is the basic wind finding technique we use in the mountains. It tells us where the upflows and downflows are. That means tucking in tight to the hill, as close as one rotor blade away to stay in the boundary layer, and maintaining a constant altitude 50 to 100 feet below the top of the mountain. Here you're sure to be below the demarcation line and can get a good feel for the actual wind conditions in the area. We then employ two types of recce techniques at eye level to assess the LZ and the winds at that altitude. They are the circle recce and the figure 8 recce. The circle recce, although of a great deal of use in the flatlands, sees limited use in the mountains, only in light wind conditions and only for crowns or pinnacles. It forces you to fly in bad air and makes you give up your drop-off for a large portion of your pass. In all mountain flying, you should maintain that safety valve, the drop-off area that you can head for just by easing in forward cyclic, losing altitude, but gaining airspeed and lift. Remember, all the power in the world in the form of collective won't keep a helicopter flying at this altitude in adverse downflowing turbulent conditions without sufficient airspeed. The figure 8 recce has become known as the basic mountain recce. It is by far the most widely used in these regions because it maximizes the time spent in good upflowing air, lets you do all your turns toward your drop-off, and keeps you out of the bad air. A modified form of this figure 8 can be used in almost every situation with very effective results. Let's go through the basic procedure for flying recces on, approaching, landing on, and departing from a crown, one of the simplest topographic features you'll encounter. Then we'll talk about the other key points you need to watch for while operating on and around some other basic terrain features. First, assess the wind direction by flying contour crawls on both sides of the hill. Next, move to the good air side and set up a 40-knot eye-level pass of the landing zone you're considering. Make a mental note of all the information you need to gather, like power requirements, size, shape, slope, and surface of the LZ, relative ground speed, approach and departure paths, and the proximity of the drop-off. When you've passed the LZ, increase your speed to 50 or 60 knots and reverse your direction at a convenient spot. Do your second pass at the same speed and altitude as the first, noting differences in power required, relative ground speed, and how the approach and departure paths look from this angle. It now takes 60 torque to maintain your 40 knots, and your relative ground speed passing the intended LZ is much faster. These differences are telling you something about the wind factors. Do more passes until you're comfortable, constantly repeating your wind-finding checklist: airspeed, altimeter, outside. Time is not wasted doing recces, especially when you're unsure of all the factors in play. All this information gathering should result in you setting up a visual picture of the approach, landing, and departure procedures you're going to attempt in these particular conditions.
Just follow along the contour.
Next, you want to confirm that the approach, departure, and LZ you've pinpointed are going to work. Make some approaches to overshoot, as many as you need to be comfortable, while still maintaining translational lift. These approaches should be the same as the final approach, aiming for 75 feet above the landing zone as a starting altitude. Assess the wind conditions from the various indicators we've talked about and prepare for a final approach. On final, you follow the same procedure as your other approaches, except of course you'll have to slow to 0 ground speed by the time you reach the landing site. It takes a bit of practice to judge the proper rate of slowdown on approach at these altitudes. If you aim to have your speed down to a walking pace, by the time you cross the near edge of the landing area, you should have no trouble reducing to 0 forward speed without having to flare, a move the flat approach and landing is designed to avoid. As we talked about earlier, the departure is also designed to give you every extra advantage in this challenging environment. After you've done all your ground checks and wind checks, review all the variables along your departure path. Then, slowly pull into a low hover, watching for any evidence of instability or problems, and ease into forward flight toward the drop-off. That's the standard recce approach, landing, and departure for any piece of terrain. But each topographical feature carries a few of its own tricky idiosyncrasies. Pinnacles can be treated similarly to crowns, but as we mentioned, they have a lot more turbulence associated with them. Do a circle recce until you pinpoint that unstable air, then switch to a figure 8. Downwind passes should bring you as much information as upwind ones. Try to stay clear of the demarcation line. It's very turbulent on a pinnacle. Use a steeper approach if you have to, and land on the upwind side to avoid backlash. Also remember, you're not going to get much ground effect. There's very little ground to get it from. With ridges, look for a landing point in the forward edge of the possible area or the highest point if there is one. Keep the aircraft in trim, the crab angle keeping the nose into wind, and look at both sides of the ridge using a figure 8. Ideally, you should try to stay upwind on a ridge, but the topography may force you to approach from the downwind side. If that's the case, find the demarcation line and stay above it out of the bad air. Never turn into the ridgeline and sacrifice your drop-off. Large, shallow saddles allow the classic figure 8 recce once you've found the upwind side. If you have to pick a landing zone that is some distance in from the drop-off, work in slowly, watch out for backlash and other wind factors, and pick a spot with the straightest, clearest approach possible. Small, deep-set saddles require a modified figure 8 recce. Gain 100 to 150 feet on the upwind side before you pass over the saddle to compensate for the lack of drop-off downwind. Stay in the boundary layer and work down to low overshoots, only going upwind. Shoulders lend themselves to a basic mountain or figure 8 recce as well. Work your way in looking for a landing zone near the edge to avoid backlash. If you have to land farther in, proceed slowly and watch for turbulence. Canyons can be very treacherous. There's often a lot of turbulence if you have any kind of strong winds at all. Do 50-knot recces up the hill, looking for landing sites and a place to enter the canyon. Then, work downhill once you're inside. Landing or takeoff need to be downhill, so you maintain your escape route drop-off. If you really want to try landing in a cirque, first check your blood pressure and temperature, then the sun and the boundary layer to see if it's possible. Then, work your way down, starting with a recce around the rim at 40 knots, trying to stay in the good air, and then progressively lower recces of about 300 feet each time, less if it's turbulent. Double and triple check your power requirements as you encounter areas of bad air, and you will. Once you're at eye level with the bench at the back, do your normal recce and approach procedures. You should end up landing into wind and downhill so you don't sacrifice drop-off. But if you can find a better place to land that'll do the same job, don't even venture in here. So that's a look at the procedures we follow to safely execute reconnaissance, approaches, landings, and takeoffs on various typical elements of mountainous terrain.
Fokker 7, check the mark, sir. Okay, level clear, the wind 330
and Mountainous regions of the world can be very dangerous to a helicopter and its pilot. But with the knowledge of the correct procedures and proper mission planning, you can begin to develop skills that help you minimize the dangers and allow you to operate safely here. Whether you're flying the Himalayas, the Urals, the Rockies, or the hills that border your valley, understanding the basic glacial structures and their effects on the wind currents will aid you in flying them effectively. Of course, it's always a good idea to get as much local information as you can about wind patterns, temperature, elevations, vegetation, and regional anomalies before you fly. One last point to watch for in the mountains is optical illusions. They fooled many a pilot who felt he was doing everything right, but was beaten by the unfamiliar territory. Illusions can take the form of total whiteout, hiding dangerous cornices, or the floor of a snowfield or glacier. The odd placement of various terrain features can give the impression that a spot is higher or lower than it actually is. On this approach, we're flying at 3,300 feet indicated, the same altitude as the intended landing zone. As you can see, it appears that we're well above the landing spot. If you flew this approach without knowing that you were at the same altitude, you'd descend and end up below and short of your LZ, without the power or airspeed to complete your approach safely. Illusions are dangerous and usually appear when you're out of collective and out of ideas. That illustration simply serves as one final reminder that the mountains are no place to take lightly. You'll need every bit of power your aircraft can provide, and you'll need every bit of information you can find to make a safe landing. Information about the different kinds of winds affecting the boundary layer you want to operate in. Information about the various features of topography in the immediate vicinity and how they're going to affect the winds and therefore the safe operation of your aircraft. And once you've assessed all the factors and indicators you can, you need to develop a skill at creating the visual picture that will allow you to effectively execute the maneuvers you need here in unfamiliar and forbidding territory. You don't need to fear these rocks, but you do need to respect them. They've been here a long time. They'll be here after we're gone. Every approach, every landing, every takeoff can be a safe one here if we carefully pay attention to the indicators that warn us of potential danger and react correctly to them with a precise and smooth application of the controls. Flying in the mountains is challenging, demanding, and at first, even a little frightening. But with the right knowledge and skills, the correct procedures, and a lot of respect, you can master them.
We're dropping down now. Okay, where is that? Okay, I'm flying 030.
Roger, I'll fly off of you. Maintain 80 knots if you can.
Pick it up here a bit.
Roger, check that.
The tower, Gander Blues, you're 2 miles back for landing.
Gander Blues, last round land, the southwest corner, your discretion, winds 330 at 5.
Gander Blues.
Roger, check that. I'm about a half mile back behind you on final now.
Okay.